Welcome back to my calculus fans. It's time for us to do another set of notes. These are the notes on the derivative of the inverse of a function. There are two different ways that we can approach these problems. If I can get my pen working. Haha, okay. So derivative of an inverse of a function, there's a shortcut formula that works, and we're going to look at why it works. And it's helpful when we have information given in a table. But before we look at the shortcut, we're going to actually skip this first box and go down to this first example. So it kind of makes sense. If we want to find the derivative of an inverse, we would find the inverse first. Okay. So the first thing I'm going to do is I'm going to take, and I'm going to go ahead and do this in problem 1. I'm going to take, no I'm not, still not. Oh, see, it's just like being in class with me. No different. Please work. Yay, okay. So the first thing I'm going to do is I'm going to take my function, y equals x cubed plus 1, and I'm going to find the inverse. And in order to find the inverse, you switch x and y. X equals y cubed plus 1. This is the inverse. Okay. Now we have to remember that when we're taking the derivative of the inverse, we are in inverse world. So in problem 1, where it says find the derivative of the inverse of f at x equals 9, that's at x equals 9 on the inverse. And he's my inverse. So I've made my inverse. I'm going to use him in a couple minutes to figure out the y that goes with an x of 9. But before I do that, I'm going to go ahead and take the derivative with respect to x. So the derivative of x with respect to x is 1. Derivative of y cubed with respect to x, 3y squared, dy dx. Yep, it's implicit yet again. And derivative of 1 is 0. So 1 over 3y squared equals dy dx. No big deal. So that's the derivative of the inverse of f. Now, notice it is in terms of y. And this was x. So, how do you get the y that goes with the x? You plug in the x, and that gives you a y. Where do you plug in that x? In inverse. In the inverse. I'm going to come over here and kind of do a little more work here. So, that means that 9 equals y cubed plus 1. So 8 is y cubed. So 2 is y. So my 1 over 3y squared, that was dy dx, derivative of the inverse, becomes 1 over 12, right? 3 times 2 squared, 2 squared is 4, times 3 is 12. Yay, yay. We love derivative of the inverse. Piece of cake. Make an inverse, take its derivative. We got implicit. We know how to do implicit. That's no big deal. We know how to make an inverse. We're good to go. So why bother talking about any other approach? Because sometimes you don't have the equation of the function. That's where we're going to need approach 1. That's why we're going to need shortcut. Before we do shortcut, though, let's do another practice of make the inverse and take the derivative. And really, this is where you should try, and you guys are going to laugh because we'll say, pause. No, but you should try. You should stop and say, okay, let me see if you can do, let me try to do number 2 on my own. And then go back and see what she does. But you're not. So here we are. So you should be thinking in your head, she made the inverse. And then, what am I doing here? That's right, taking the derivative of the inverse with respect to x. Not going to get too bent out of shape about simplifying this algebraically in variable form because I'm going to plug into it. So there's my derivative of my inverse. The derivative of the inverse of that square root function. Now, of course, we're not going to plug in x equals 2 because this is in terms of y. We also have to make sure we remember, and I always write this down because this is where I got so confused the first year I taught this. Like, it was the worst lesson I ever taught since probably the first year I taught back in 1993. I was teaching 8th grade and I was like clueless. X equals 2 is on the inverse. So make sure when you're plugging in, substituting in x equals 2, you are doing it in inverse world. To figure out, or y, because this bad boy is in terms of y. 1 over 1/2, 8 minus 4 to the negative 1/2. Now, if you were wimpy, you'd be like, I need my calculator. But you don't, because you're tough, because you're calculus students. So you realize that's 1/2 times 1 over the square root of 4. That's 1 over 1/2 times 1/2. 4. Hooray! Now, we're going to show a calculator problem in a couple minutes. But let's go back now and take a look at this shortcut that I'm talking about. I keep saying there's a shortcut. There's another way to do the problem. Move this guy out of the way. All right. So here's how we can sort of see where the shortcut comes from. If I have two functions that are inverses, one thing I'll know about them is their composition is equal to x. So here is a relationship, something where I can see I'm relating two functions that are inverses. Okay, so f and g are inverses. If I take the derivative of that relationship, the derivative of f of g of x, that's f prime of g of x times chain rule g prime of x equals 1. Now, officially in this case, we're going to let x or f count for the regular function or the original function, and g count as my inverse. So that's going to mean that g prime x is the derivative of the inverse. So if I solve for that, g prime of x is equal to 1 over f prime of g of x. That's 1 over f prime at y from the inverse. Okay. The derivative of the inverse is actually going to always come out to be 1 over the derivative of the original, but with y plugged in from the inverse. Now, I know right now you're going, what did she just say? I have no clue what the heck she means by that. But if I do it, if I compare approach 1 and approach 2, you'll see, go, oh, it's a shortcut. Approach 1 says, take my original function, y equals x cubed plus 1, and take its derivative. Okay, so y prime is 3x squared. So supposedly, the derivative of the inverse then is 1 over 3y squared. Holy crap, look at that. Now, you still have to figure out what to put in for y, because it's not 9. So you can do that a couple different ways. You're still going to have to think about what y is on the inverse for an x of 9. So still we'll have to figure it out a slightly different way when we're given a table. We'll jump off that bridge in a minute. But I think the easiest way in an equation is to do exactly what we did over here. Still write the inverse, still write the 9 in here. Figure out that y is going to be 2, 1 over 12. If you try it on number 2, you'll see the exact same thing happen. If you take the derivative of the square root of x minus 4, you're going to get something that looks just like this. I put 1 over it, I change my x into a y, I figure out what the y is that I need, bam. I like that I'm making a video for this because you can actually go back and look at this again and listen to me talk about it more than once, because I think that will help. You kind of, if you think about it a lot, you start getting eyes crossed and confused, but what helps me is I label everything and I try to keep really straight. This is original function, this is inverse. All right. I'm going to leave this one for you to practice because I want to show you how we're going to do a calculator problem. Now, how we're going to do a calculator problem isn't any different until we get to the point where we're trying to figure out what to plug in, because that's going to be the tricky part. Now, so on problem number 4, whether I want to do this the long way or the short way, whatever you think, option 2 or option 1, I'll go ahead and do sort of the normal way instead of the shortcut way. Oops, if I can do it. Right, so there's my inverse. Inverse. So 1 equals 3y squared. It's exactly this example that when you write all these dy dx's, you're like, oh, yeah, shortcut would just help. So 1 over 3y squared minus 8y plus 7 equals 2y dx. The derivative of that, but in terms of y instead of x. 3x squared minus 8x plus 7. But in terms of y's. Try that again. 3y squared. Yeah, that's the only thing bad about the video is all my mistakes are recorded. Okay, so here we go. We have our derivative of our inverse formula. Now we just got to figure out who to plug in. X equals 1 on inverse, not what I need to plug in. I need the y that goes with x equals 1 on inverse. So 1 equals y cubed minus 4y squared plus 7y plus 1. Here's where your calculator comes in. The only way, well, not the only way, but the easiest way, and the way we're going to solve that equation, is using our calculator. Now I'm hoping that this, I would think that the calculator stuff will record, just like anything I'm doing. We'll see. La la la. Just like in class, it's going to be painful watching me put it in the calculator. I should have done it before I taped. Ugh. Dummy. Okay. See, or I should have done that problem because I already had it in there from 5th period. Okay. So, how do we solve scary equation? We graph. We graph. Y equals 1. Boop. We graph the other one. We type it in terms of x because the calculator doesn't really care. Just need to have a variable. It's just as easy to type it in x. Where's my squared? There he is. Mr. Squared is not working. I hate him. Oh, okay, there he is. 7x plus 1 graph. And let's see. Check I. Okay. Yeah. Zoom in a little bit. There's my y equals 1. There's my squiggly cube. And so I'm going to tell it to calculate, second, and the trace button to get to calculate the intersection. There's my first function. There's my second function. That is not where they cross. No, it's not. If you were sitting with me, you'd be telling me what I'm doing wrong. What am I doing wrong? Maybe that is where they cross. Well, that's a crappy example. That can't be. Oh, did everybody see it? Everybody at home's been yelling it. It's a minus! When's she gonna realize it's a minus? Oy. Okay. Which didn't matter here because it didn't matter on the derivative, but okay. Let's try that again. Now see, if I were a less honest person, I would just retape word over that. But I'm not. Nobody's perfect, and you need to know that that's okay to make mistakes. Minus 1 graph. Heck yeah, okay. There we go. So we find, I calculate the intersection, first curve, my second curve, and where do they cross? They cross right there. And that crazy number, that 349 number, is my y. if you're smart, you let your calculator do all the hard work for you. That number has been stored as the answer variable. There it is. I'm going to restore it. So I'm just going to hit the store button. I'm going to store it as X. So now, when I want to calculate something with that, I'm going to use my calculator. And I'm going to type it in terms of X. So this thing alpha F1. Here comes the custodians, even though I hung a note on my door not to come in. They're gonna come in anyway. Still whispering. Okay. Enter. 0.218. So what would we want? So my dy dx is approximately 0.218. You could also put 0.21, not 9, 0.219. You can truncate, which is just fancy for chopping it off, or you can round. So 2187, either chop or round. Okay. You're going to have a calculator one on your test. So practice your calculator problems. I'm going to stop here. I will get you some more information on the table problems in a follow-up video. This is already pretty long for you to deal with. So practicing this calculator problem and practicing this. No calculator, because really it's about practicing the process. So calculator versus non-calculator. We'll wait on this. I'll show you how to do the table problem so that if we have to do a table problem, we can. And then in the practice problems, I think we're pretty much equation based. This is a little tricky. This is kind of a table problem. Okay. This is good. So make sure you do the practice of the basics so you understand the process. Make sure you do the practice with your calculator that you can do it accurately. That'll be enough to get you through your test. And then before we that doesn't make any sense. Before we wrap up completely jump ship on our calculus information leading to the AP, we'll make sure we go back and talk about the table. Okay, that's it for today. Have a great weekend. Are we praying for snow? I don't know. See you soon. Bye.